Section 22.25 1,2 insertions and β-Hydride elimination. 1,2 insertion reactions are often observed with eta-2 ligands, such as alkenes. In this complex, this metal is bonded to X and also a ethylene molecule. In this ethylene molecule, we have both carbon atoms donating their p electrons to this metal. And now this X will move to this carbon and form this structure. You can see this carbon is 2 bonds away from the metal, and initially X is 1 bond away from the metal, and therefore this is called 1 and 2 insertion reaction. Now let's look at the electron movement. These 2 electrons will go here and become the sigma bond between X and this CH2. Over here, the 2 p electrons will become the sigma bonding electrons between the metal and this alpha carbon. So we can label this carbon directly bonded to the metal as alpha carbon. This one is then the beta carbon. Beta-Hydride elimination is the reverse of 1,2 insertion and can be used for isomerization of alkenes. For example, if this one is hydrogen, it can move to this metal and form this alkene bonded to metal, and this hydrogen is also bonded to metal, and this is called beta-Hydride elimination because we are removing this hydrogen from the beta carbon. Now let's look at the isomerization of alkenes. Right here you have this double bond in this 1,2 position between carbon 1 and carbon 2. And now we can do 1,2 insertion reaction and move this metal to here, this position. This hydrogen is now bonded to the terminal carbon. And now if you look at this structure may undergo beta-Hydride elimination. So imagine there's a CH2 functional group here. One of the 2 hydrogen atoms can move to the metal. And now you form a double bond between carbon 2 and carbon 3. The end result is the shift of the double bond from position 1 to position 2. Beta-Hydride refers to the hydrogen on the second carbon atom from the metal atom. So over here, this is metal, so this is alpha carbon, this is the beta carbon. And this beta carbon loses 1 hydrogen to this metal. Therefore, it's called beta-Hydride elimination.